Determining geometric means. The first and the last terms of a given geometric sequence are called extremes, and the terms between these are called means. Let us have examples. Example number 1. The given geometric sequence is 1, 2, 4, 8, 16. In this given geometric sequence, our 1 is the first term and our 16 is our last term. So our 1 and 16 here will be considered as geometric extremes. And the terms between 1 and 16, such as 2, 4, and 8, will now be considered as geometric means. How are we going to find the geometric mean or means? A geometric mean between two terms can be found using positive negative square root of a times b. On the other hand, if there would be more than one geometric mean to be inserted, we will now employ the formula of R, or the formula of the common ratio, and that is R equals n minus 1 root of a sub n over a sub 1. Example number 2. Insert one geometric mean between 9 and 16. The given here will be the first term, or the a sub 1, which is 9, and a sub 3, or the third term, which is 16. So we have here a sub 3 because we only have to insert one geometric mean. And this one geometric mean will be the second term, or the a sub 2. So therefore, we need to find for the a sub 2, or that would be the geometric mean between 9 and 16. So since there is only one geometric mean to be inserted, we can now use the formula of the positive negative square root of a times b. Our a will be the first term, and our b will be the third term, or the last term. So let us now solve. By substitution, we have positive negative square root of our a again is 9, and our b will be 16. Simplifying this, 9 times 16 is equal to 144. Getting the square roots of 144, this will be equal to positive or negative 12. So therefore, our geometric mean here will be positive or negative 12. Example number 3. Let us insert 3 geometric means if the first and the last terms are 4 and 64 respectively. In our given, we have a sub 1, or the first term, which is 4. We have a sub 5, or the last term, which is 64. So we use a sub 5 because we have already the first term, and we need to insert 3 geometric means. So that means our 64 will be the fifth term, and our n will be equal to 5. We have 2 given terms, the first and the last term, plus the 3 geometric means to be inserted. That's why our n is equal to 5. What we need to find here first would be our common ratio. So to find this, we use the formula of R, which is n minus k root of a sub n over a sub k, or our k here will be replaced by 1. If we're going to illustrate that, we have 4 as the first term, our 64 as the last term, and the 3 terms to be inserted between these two numbers. Using again the formula, let us now substitute. Our n is 5. We have 4 as number 1. We have the 3 terms to be inserted. And then the last term, or the 5th term, which is 64. So we have 5 minus 1, root of our a sub n, or the last term here, is 64, over our a sub 1, which is 4. Simplifying this, we get 64 divided by 4. And the answer is 16. Let us now get the 4th root of 16. And the 4th root of 16 will be equal to positive or negative 2. So the common ratio here will be positive or negative 2. Since there are 2 common ratios here, so there are also 2 sets of geometric means. So first, if our r is equal to positive 2, so 4 times 2 equals 8, 8 times 2 equals 16, and 16 times 2 equals 32. So the geometric means first will be 8, 16, 32. For the second set, if our r is equal to negative 2, we have 4 times negative 2 equals negative 8. Negative 8 times negative 2 is positive 16. And positive 16 times negative 2 is equal to negative 32. So the second set of the geometric means will be negative 8, positive 16, and negative 32.